This is homework 2, question 20, the last of the challenging questions on MyLab. I have r of p is equal to the fourth root of p times, in brackets, the second root of p minus 3p plus 7. I need to find the first and second derivatives of this function. Always, 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 I first see if I can rewrite my function to take an easier form to do the derivatives. So we're going to look to see if we can get it in the form of ax to the power of n. And this is just my original function, no derivatives being done yet. So I have r of p is equal to, now I have this fourth root, so that's going to be p to the power of 1/4. And now I have in brackets this other term, so I have the second root, so that's p to the power of half, minus 3p plus 7. Okay, I still don't have this entirely in the form of ax to the power of n because I've got this bracketed expression. We will learn the rule of how to do the derivative of two products next week, but there is an easier way through simplification. And that ties into our rules that we have this week. So now I'm going to multiply p to the power of 1/4 into the brackets so that we can FOIL this out. So first, p to the power of 1/4 times p to the power of half minus, now I'm going to multiply p to the power of 1/4 times negative 3p times p to the 1/4, and then times 7 plus 7p to the power of 1/4. I'm going to simplify this further using our rule, x to the power of a times x to the power of b is equal to x to the power of a plus b. That's from pre-calculus. So I have the same base here, so I can add these exponents. So I was going to add these exponents, 1/4 plus half. Now I'm going to need to give this a common denominator. So I have 1/4 plus 2 quarters, giving me 3/4. So that's going to be adding up those exponents. So that will give me p to the power of 3/4 here. Looking at the next term, minus 3. Now I have p to the power of 1. Let's not forget that when we don't have an exponent, it's implied that it is 1. Adding up 1 plus 1/4, adding up those exponents, is the same as 4/4, because I need to give it a common denominator, plus 1/4. So now I can just add up the numerators. I have 5/4. So this is going to give me, let's change that to blue, p to the power of 5/4. And there's nothing to be done with that last term. It's 7p to the power of 1/4. So now I have rewritten my expression so that it's easier to just use the power rule of derivatives to do the derivatives here. So now the first derivative, using our power rule, where if we have y is equal to ax to the power of n, then dy by dx is equal to an x to the power of n minus 1. So for our first term here, I'm going to pull back that exponent, 3/4, p to the power of 3/4 minus 1 or minus 4/4. For our next term here, I have negative 3, the coefficient just goes along for the ride, then I pull back that exponent, times 5/4, p to the power of 5/4 minus 1 or minus 4/4, same thing as 1. Plus 7 for our last term, the coefficient just goes along for the ride, and I pull back that exponent, times 1/4, p to the power of 1/4 minus 1, or we can write it as 4/4. Now simplifying this, I have 3/4 p to the power of, I collect my numerators, 3 minus 4, negative 1/4. Here I multiply the 3 times the 5, I get negative 15 over 4. P to the power of 5/4 minus 1/4 gives me positive 1/4. Plus 7 over 4. P to the power of, I have 1/4 minus 4/4, leaving me with negative 3/4. So that is my first derivative. For my second derivative, I'm going to continue to use the power rule, looking at this one term at a time. So my first term, 3/4 p to the power of negative 1/4. 3/4 is the coefficient, it just goes along for the ride. I pull back that exponent of negative 1/4. P to the power of negative 1/4 minus 1, or minus 4/4. Looking at our next term, negative 15 over 4 will be the coefficient that just goes along for the ride. Pulling back that exponent times 1/4, p to the power of 1/4 minus 4/4. Now looking at our last term here, 7/4 is our coefficient, just goes along for the ride. Pull back the exponent, negative 3/4, p to the power of negative 3/4 minus 1, or minus 4/4. Cleaning this up, I'm going to multiply my numerators. 3 times negative 1 gives me negative 3, and then multiply my denominators. 4 times 4 gives me 16. P to the power of, I have a common denominator already established, so I have to add up the numerators. Negative 1 minus 4 gives me negative 5/4. Now for our second term, I'm going to multiply my numerators, minus 15. I'm going to multiply my denominators, 16. P to the power of 1/4 minus 4/4 gives me negative 3/4. And then for our last term, multiplying my numerators, I get negative 21. Again, multiplying my denominators, I get 16. P to the power of negative 3/4 minus 4/4 gives me negative 7/4. And that is my second derivative.